Alright, hello everyone who's watching this. I'm Leandra. Today I'm going to be presenting to you a review of the study Estimating Mangrove Tree Biomass and Carbon Content, a comparison of forest inventory techniques and drone imagery. The study was conducted by the University of Adelaide in partnership with the South Australian Department for Environment and Water. It was published in Frontiers in Marine Science earlier this year. I want to begin by acknowledging the Widjabul people of the Bundjalung nations whose unceded lands I am presenting this from. I'd like to further extend my acknowledgement to the custodians of the lands wherever you may be watching this. Alright, so the study explored the potential of unarmed aerial vehicle imagery to create 3D models of mangrove tree structure to estimate above ground biomass and carbon. The study was undertaken in South Australia, where forest inventory was conducted on a mangrove forest composed of Avicennia marina, which is a protected species. However, researchers were able to obtain trees removed destructively as part of a road project. Mangroves provide many ecosystem services, including carbon storage, shoreline protection, and they act as nurseries for many marine species. But their remoteness and predators can make it difficult to access them. So the potential for implementation of UAV generated imagery could provide researchers access to otherwise inaccessible areas as well as reduce time-consuming fieldwork. Researchers used in this study traditional biophysical measurements of destructively harvested trees to compare the UAV results against. Research compared other derived variables such as DBH, tree height, and D30. So how did they do it? 10 trees were flagged above the canopy, and a 20 megapixel Sony RXI100 III camera was hard mounted onto a 3D Iris-C UAV to capture RGB images of the mangroves from 40 meters above the ground level. A nominal spatial resolution of 1.5 centimeters was then generated with the Pix4D Mapper Pro photogrammetry software. The digitized canopy extents were used to compute the canopy area in meters squared of each tree. After which the marked trees were then felled, and height, weight, DBH, tree diameter, biomass, and carbon content were recorded. Researchers were unable to directly measure the canopy areas due to site-restricted access, and data analysis were performed on a suite of measured and modelled metrics relevant to biomass. In addition, data from the UAV imagery was used to model DBH and D30. So what did they find? Researchers used both direct measurements and the UAV imagery to calculate several variables. They calculated the mean predicted error in kilograms for both methods and then compared them. The UAV imagery base variables had a much higher mean predicted error than the direct measurements. As you can see, the lowest one sort of here is 17.41 kilograms, which is still a large error. And this is a point cloud used in the study. So what are the implications of this? Although the UAV image-based results did have a high error, researchers were able to test several already published allometric equations on the species, as well as one they did of their own design to see which equations had the smallest mean predicted error. Researchers actually found that their own developed equation had the most accurate results using multiple predictive variables to calculate the biomass. The most effective predictive variables being DBH and D30. So the study did actually demonstrate the potential for using UAV image-based models for mangrove structure to extract other variables used to estimate above ground biomass and carbon. UAV image data was able to model tree height with high accuracy and log DBH and log D30 with reasonably well. However, the UAV image data did predicted above ground biomass poorly. But despite the low accuracy results from those methods, researchers were able to develop the best predictive variables that can be used and can be focused on for further refinement in modelling in the future. And there is little existing data set on the South Australia A Marina because it's predicted. So the access to these trees enabled researchers to build upon the existing knowledge and to develop efficient allometric equations that can be applied directly to a marina that grows in the unique climatic niche on the South Australian coast. The research shows the potential for this technology to be refined and implemented and provides a baseline for further research to be conducted. And that's the reference there.